for adding and subtracting rational fractions. We're going to start off just by looking at how to add or subtract fractions. Some with like denominators, some with unlike denominators. Your whole idea is to have the same denominator in order to add these fractions. So if we look at the first set, we have 1/5 times 3/5. We can just add the numerators and it'd be 4/5. We're going to keep the denominator, add the numerators. Same thing with subtracting. Subtract the denominator or subtract the numerators, keep the denominator as long as the denominator is the same. So if we look at the next one, 6/7 minus 4/7, the 6 minus 4 is 2, keep it over 7. However, for the next one, you have 1/2 plus 2/3. You don't have a common denominator. Your greatest common or your least common multiple of 2 and 3 is 6. So we would multiply the 2 by 3. We would do the same with the 1. So this is going to become 3 over 6. The 2/3, you would multiply the 3 by 2. So you'd multiply the 2 by 2 as well. And that would give you 4/6. We can add these now. The 3 plus 4 is 7. Keep it over the 6. If we look at our first set of examples with these rational expressions, your whole idea is to look at these as if there are parentheses around them. Okay, so like for example A, we would have 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. Put parentheses around those binomials so that way you know that nothing's happening, especially with those denominators if they're the same. So in this case, our denominators are the same. The only thing we have to do is combine our like terms on the numerator. You would put parentheses around this specifically if you are subtracting, so that way you know in order to subtract you have to distribute that negative into the second numerator. So from here, the 3x plus the 2x is going to give us 5x, and the negative 4 plus the 5 is going to give us a positive 1. So this is 5x, put parentheses around it if it helps you, over x plus 3. If we're telling where our expression is undefined, again, you take that denominator, x plus 3, set it not equal to 0, and tell me that x cannot equal negative 3. So x cannot equal negative 3 as well. So this whole thing is your answer. If we look at B, we have 2x minus 1, put parentheses around it if it helps, over x squared plus 2, again, put parentheses around it if it helps, minus 4x plus 4 over x squared plus 2. So we're going to rewrite this to be 2x minus 1 minus, parentheses, 4x plus 4 all over x squared plus 2. So we need to remember to distribute this negative. So it's going to become 2x minus 1 minus 4x minus 4 over x squared plus 2. The 2x minus the 4x is going to give us a negative 2x. And then the negative 1 minus the 4 is a negative 5. So it's negative 2x minus 5 over x squared plus 2. And then x cannot equal the square root of plus or minus square root of negative 2. How did I get that plus or minus square root of negative 2? If I take that x squared plus 2, set it not equal to 0, I'm going to move the 2 over by subtracting it. Then I have x squared is not equal to negative 2. Take the square root. Whenever you take the square root and it's not equal to or equal to x or a variable, you have to give the plus or minus of that. So x is not equal to plus or minus the square root of negative 2. For C, we have 6x plus 5 over x squared minus 3 plus 3x minus 1 over x squared minus 3. So our denominators are the same. We're just going to combine like terms on the top. So 6x plus 5 plus 3x minus 1 all over x squared minus 3. The 6x plus 3x is 9x. The 5 minus 1 is a positive 4. So 9x over 4, 9x plus 4 over x squared minus 3. We're also going to tell that x is not equal to something. So remember, x squared minus 3 is not equal to 0. Move the 3 over. You're going to have x squared is not equal to 3. Take the square root of both sides. Put that plus or minus out in front of the radical. So x cannot equal plus or minus the square root of 3. For D, we have 3x squared minus 5 over 3x minus 1 minus 2x squared minus 3x minus 2 over 3x minus 1. We have like denominators, so the only thing we have to do is combine those numerators. So we're going to have 3x squared minus 5 minus, put parentheses around the second numerator, 2x squared minus 3x minus 2, close parentheses, all over the 3x minus 1. So we're going to distribute that negative. The 2x squared is going to become negative, the 3x will come positive, and the negative 2 will become a positive 2. We're going to have 3x squared minus 5 plus 2x squared plus 3x plus 2 all over the 3x minus 1. So from here, we're just going to combine like terms. The 3x squared plus 2x squared is going to give us a 5x squared. The negative 5 and the positive 2 is going to give us a negative 3. And that positive 3x is going to stay a positive 3x. Keep it over the 3x minus 1. Now, when you go to rewrite this and tell me what x is not equal to, you want to put it in standard form, especially with your numerator. So it's going to be 5x squared plus 3x minus 3 over 3x minus 1, where x cannot equal 1 over 3. For our next part, we are finding the least common multiple here. So if we look at A, we have 2x cubed y to the 4th and 3x to the 5th y cubed. So our least common multiple between the 2 and the 3 is 6. We're going to keep the highest exponent for each variable. Any variables that's not the same for both, we're going to write that down as well. So we have x cubed and x to the 5th. We're going to keep the x to the 5th. And then we have y to the 4th, y to the 3rd. We're going to keep y to the 4th. So 5x to the 6th, y to the 4th is our least common multiple. For B, we have to factor these. So that x squared plus 3x minus 4, the factors of negative 4 that add up to be 3, are a positive 4 and a negative 1. For the x squared minus 3x plus 2, the positive 2, positive 1 are going to be our factors of that 2 that give us a negative 3. So what's the same in these? The x minus 1s should be the same. These are minuses. Minus, hold on. So we have a minus here and a minus here. All right, so these should be negatives. So the x minus 1 is the same on both, so we're going to rewrite the x minus 1 just once, and then we're going to rewrite anything else that just occurs once as well. So it's just x minus 1 times x plus 4 times x minus 2. And we're going to keep these factored. We're not going to multiply them out or anything. We're going to keep them factored because that'll help us when we go to do those subtraction problems or addition problems with those expressions in the fractions. So we can simplify. If we look at C, we have 4x cubed y to the 7th and 3x to the 5th y to the 4th. The 4 and the 3, the least common multiple is 12. We're going to keep the x to the 5th and the y to the 7th. So 12x to the 5th, y to the 7th. For D, we have x squared minus 4, which is going to factor out to be x minus 2 times x plus 2. For the next trinomial, you have x squared plus 5x plus 6. The factors of 6 that add up to be 5 are 2 and 3. So this would be x plus 2 times x plus 3. So what's the same on both of them? Those x plus 2's. So we'd write one of those, and then rewrite everything that also occurs. So the x minus 2 as well as the x plus 3. So we have x plus 2 times x minus 2 times x plus 3 for this one. If we look at our next set of examples, these fractions do not have like denominators, so you have to factor whatever you can and turn them into two fractions with the same denominators. When we do this, we want to factor first, so this first fraction is going to stay x minus 1 on the top. The bottom is going to be x plus 1 times x plus 2. For that second fraction, that x plus 1 is going to be multiplied by x plus 2 because that's what's missing from the first one. And we'll do the same on the numerator as well. So we're going to have x times x plus 2 on the top. And then the bottom is we're going to have x plus 1 times x plus 2. So from here, we want to go ahead and multiply that x in. So distribute it. We're going to have x minus 1 plus x times x. So that's going to be x squared. And then that positive x times 2 is a 2x all over x plus 1 times x plus 2. If at this time you wanted to tell me what x can't equal, you can do so. You can do that x plus 1 is not equal to 0 and that x plus 2 is not equal to 0. So we know that x cannot equal -1 or -2. So from here, go ahead and combine your like terms in your numerator as well. You're going to have x squared. You have an x and a 2x, so it's going to be plus 3x minus 1 over x plus 1 times x plus 2. That x squared plus 3x minus 1 cannot be factored. It is prime, so the only thing else that you have to do is tell me that x cannot equal -1 or -2. And this would be your answer. For B, we have x over x plus 3 plus -18 over x squared minus 9. That -18 over x squared minus 9 is going to turn into -18 over x minus 3 times x plus 3. The first fraction we're missing that x minus 3 from, so we're going to multiply the x by x minus 3 on the top in order to add these. So we're going to have x squared minus 3x over x plus 3 times x minus 3 as well. So we can combine like terms because we have addition there, so it's going to be x squared minus 3x minus 18 all over x plus 3 times x minus 3. We also know that x cannot equal a positive or a -3 here, because if we set the x plus 3 not equal to 0 and then the x minus 3 not equal to 0, we get that x cannot equal plus or minus 3. Your factors of that 18, that -18, we want to see if there are any that can give us a -3. So we have 1 and 18, 2 and 9, 3 and 6. The 3 times 6 is 18. If we had a -3 times plus a positive 6, that's going to give us a -3. We're looking for a -3. So we're going to factor this out to be x plus 3 times x minus 6 over x plus 3 times x minus 3. And x cannot equal positive or -3. We have those x plus 3s that can cancel out, so we're just going to be left with x minus 6 over x minus 3, where x is not equal to plus or minus 3. So that one's a little bit more in depth there. If we look at C, we have 3x over 2x minus 2 plus 3x minus 2 over 3x minus 3. So I'm going to start by factoring these. We're going to have 3x over 2 times x minus 1 plus 3x minus 2 over 3 times x minus 1. So each of these have x minus 1. The first is missing a 3, so we're going to multiply the top and bottom by 3. The second, we're missing a 2, so we're going to put parentheses around that numerator and distribute in that 2. So this 3 times 3x is going to give us 9x over 6 times x minus 1 plus 2 times 3x is 6x. 2 times -2 is -4 over 6 times x minus 1. So from here, we have 9x plus 6x, which is going to give us 15x minus 4 over 6 times x minus 1. And then x cannot equal 1. We would, for this, set that least common denominator not equal to 0. So the 6 is not equal to 0. That we don't have to worry about because there's no variable with that. And then the x minus 1 is not equal to 0. So that one would go ahead and give us that x is not equal to 1. For D, we have x over x plus 3 plus 2x plus 6 over x squared plus 6x plus 9. So I'm going to factor that second fraction's denominator, leave the first, put parentheses around it. I'm also going to leave that numerator on the second fraction to stay the 2x plus 6. That's x squared plus 6x plus 9 is going to be x plus 3 times x plus 3. We're missing the x plus 3 from the first, so I'm going to distribute the x into the x plus 3 to give me x squared plus 3x over x plus 3 times x plus 3, and just combine my like terms here with my numerators, giving the plus 2x plus 6 on the top as well. My x squared is going to stay. 3x plus 2x is 5x, and then that plus 6 stays as well. So I'm going to have that over x plus 3 times x plus 3. Either way, x cannot equal negative 3 here. And then we have, then we have to factor that x squared plus 5x plus 6. The factors of 6 that add up to be a 5 are a positive 2 and a positive 3, so it's x plus 2 times x plus 3 over x plus 3 times x plus 3. Those x plus 3's would cancel, so we would just be left with x plus 2 over x plus 3, where x is not equal to negative 3. For our next example, we have 2x squared minus 16 over x squared minus 4. We're going to factor that first. It's going to be 2 times x squared minus 8 over x minus 2 times x minus or plus 2. And then that second one, you're going to need the x minus 2 on the top and the bottom. You want to FOIL this out. And remember, when you do so, you want to keep parentheses around it. So it's going to be x minus 2 times x plus 2 on the bottom. And on the top, you're going to have x squared minus 2x plus 4x. That's going to be a plus 2x minus 8. So from here, we actually didn't have to factor out that top. Okay, so we can actually leave it as the 2x squared minus 16. So make sure you leave that there. From here, distribute that negative in. So we're going to have 2x squared minus 16 minus x squared minus 2x plus 8 all over x minus 2 times x plus 2. So from here, you can tell me that x cannot equal a positive or a negative 2 because x minus 2, x plus 2. Then you also can combine like terms. So we're going to have x squared minus 2x minus 8 over x minus 2 times x plus 2. If we factor that x squared minus 2x minus 8, the factors of 8, negative 8, are going to be 2 and 4. That negative 4 and positive 2 is going to give you the negative 8. So this is going to be x plus 2 times x minus 4 over x minus 2 times x plus 2. Those x plus 2's would cancel, so you'd be left with x minus 4 over x minus 2, where x cannot be positive or negative 2. So x minus 4 over x minus 2, where x cannot equal positive or negative 2. For f, we have 3x minus 2 over 2x plus 5 minus 2 over 5x minus 2. So this second fraction is missing the 2x plus 5. So we'll multiply top and bottom by that. And then the top one, or the first one, is missing the 5x minus 2. So we'll multiply the top and the bottom by that 5x minus 2. Your numerator here is going to be 15x squared minus 10x minus 6x. So that's negative 16x plus 4 over 2x plus 5 times 5x minus 2 minus 2 times 2x is 4x plus 10 over the 2x plus 5 times 5x minus 2. If you distribute that negative now, you are going to have 15x squared minus 16x plus 4 minus 4x minus 10 all over 2x plus 5 times 5x minus 2. So from here, combine like terms, we're going to have 15x squared minus 20x minus 6 over 2x plus 5 times 5x minus 2. You cannot factor that top any further, so you're just going to tell me that x cannot equal negative 5 over 2 or 2 over 5. So this would be your entire answer. If we look at the last one, we have 2x squared plus 64 over x squared minus 64. This is going to be 2x squared plus 64 over x minus 8 times x plus 8. That second one's missing an x minus 8. So we're going to multiply top and bottom by x minus 8. We're going to have a minus in between still, so it's going to be x squared minus 12x plus 32 over the x minus 8 times x plus 8. We're going to distribute that negative so that we have 2x squared plus 64 minus x squared plus 12x minus 32 all over x minus 8 times x plus 8. We can tell too now that x cannot equal positive or negative 8. So from here, combine your like terms. We're going to have the 2x squared minus x squared to give us x squared. That 12x will come next. And then we have 64 minus 32, which is a positive 32, all over x minus 8 times x plus 8. From here, you can factor that, and you're going to end up getting x plus 8 times x plus 4 over x minus 8 times x plus 8. So then those x plus 8s would cancel, and we're just left with x plus 4 over x minus 8, where x cannot equal positive or negative 8.